In this video, we are modeling with straight lines. That means we are using straight lines, lines in the form y equals mx plus c, to model, to represent real life situations. The first question, the example, is the world population. So the world population in 2007 was 6.7 billion. The world population in 2014 was 7.3 billion. Given n is the number of years after 2007, and p is the world population in billions, and using a linear model, so a straight line model, find an equation linking p with n. So p is the world population, so we're given that, and n is the number of years after 2007. So 2007 is 0 years after 2007, and 2014 would be 7 years after 2007. So we've got an equation linking p with n. So a straight line graph is in the form y equals mx plus c, but we've got linking p with n. So we're going to change y into p and x into n. So it's going to be p equals mn plus c. So our equation is going to be in this form, but we're going to have to work out what c is and what m is. So c is the y-intercept. That's when x equals 0. And we know what the population is when n equals 0. It's 6.7. So c is going to be 6.7. Let's just make a note of that. So c is 6.7. And we find m, the gradient, by doing, it's usually the change in y over the change in x, but in this case, it's the change in p over the change in n. So the gradient, let's do p2 minus p1 over n2 minus n1. So we'll have n1 p1, n2 p2. So the gradient is 7.3 minus 6.7 over 7 minus 0. Now use the calculator. 7.3 minus 6.7 over 7 minus 0 is 3 over 35. So that's all we need to know. So p is 3 over 35 n plus 6.7. That is the equation. So if we are asked to interpret what this number means, so for every 1, the years go up. So for every year, the population goes up by this amount. So this is the increase in the population every year. In 2020, the world population was 7.8 billion. Comment on the suitability of your model in light of this information. So we can, 2020 would be 13 years. So when n is 13, we can use the model to predict the population. So the population would be 3/35 of 13 plus 6.7. So just type it into the calculator. And we get, well, 7.8. So it seems the model is suitable. As the model predicts 7.8 billion in 2020. Okay, one for you to try. So pause the video and give it a go. So this time we've got car production. N is the number of years after 2001. we'll have 0 and 7 for N. C is the number of cars produced. Find an equation linking C with N. So it's going to be in the form y equals mx plus c, but we're changing y into c and x into n. So it's going to be c equals mn plus c. I don't like the use of c twice, but gradient and y-intercept, we'll work out what they are and then substitute them in. So the y-intercept is going to be 41.2 million. So I'll just write 41.2. I don't want to write 41.2 million. So C is going to be 41.2 million. M is going to be the change in Y over the change in X, or the change in C over the change in N. So M is going to be the change in C, 52.7 minus 41.2 over the change in N, which is 7. So 52.7 minus 41.2 over 7. So 23 over 14 is the gradient. So the equation is C is equal to 23 over 14 N plus 41.2, and it's in millions. $72.1 million cars were produced in 2016. Comment on the suitability of your model in light of this information. So 2016 will be N is 15 years after 2001. So let's substitute it in. So 23 over 14 times by 15 plus 41.2. So answer times 15 plus 41.2 gives us 65.8. 65.8 million. Comment on the suitability of your model. So it may not be suitable because it's too low. So I'll put it may not be suitable. $65.8 is less than 72.1. If we were asked to interpret what the gradient means, so it would be every year the car production goes up by that many millions. So every year the car production goes up by this amount. For every change in N, that's the change in C.